Alright, so this is your question number 3 on motion graph kinematics. It is a long question split across 2 screens, and as I always say, please try to attempt the question yourself, and then you can come back and play the video and you can see the working of it. This is the first screen of the question. It's a long question. You can take a snapshot, and this is the second screen of the question. Meanwhile, do not forget to subscribe to the channel because it is very encouraging for me and as well as for the quality of content that you see on the channel. As well as please do mention in the comments your feedback, if you are okay with the speed of the explanation, if you're okay with every other thing that is there in the video, or if you have any other inputs that you would like to include, if you would like me to include in the video, then please do suggest. Alright, so let us start with understanding the question now. I hope that you all have attempted the question yourself and you are back on the video. So let us start with the question number 1. It says define velocity. It's a 1 mark question. And the second question, distinguish between speed and velocity. It is a 2 mark question. So simple and easy. You know the formula for velocity. It is displacement per unit time. If you can write it over here, that's perfectly correct. Distinguish between speed and velocity. Here as well, if you can distinguish in terms of there being scalar and vector, that's perfectly fine. So let us see. What the mark scheme says. Either you define velocity as a rate of change of displacement, or you write down the formula for velocity, which is displacement over time taken. You get the full 1 mark. And to distinguish between speed and velocity, speed has only magnitude, it is a scalar, you can say it is a scalar, and velocity has magnitude and direction both, you can say velocity is vector. So you get 2 marks. Easy and a simple question, most basic kind of a question that you can think of. Let us come to the part B. A car of mass. Now the mass is given to you. 1500 kgs moves along a straight horizontal road. The variation with the time t of the velocity of the car is shown in this figure. So what kind of a graph it is? It is a velocity time graph. Alright. So the brakes of the car are applied from t is equal to 1 seconds to t is equal to 3.5 seconds. So let us mark these 2 points and understand where is this happening. Even if you do not mark, if you understand how the graphs look like when you are decelerating, you can automatically find where these times should be. Otherwise, let us mark these 2 points. It is 1 seconds and 3.5. Another point is 3.5 here. So this is the point that they are talking about, these 2 points. Calculate the distance moved by the car. So the distance moved, the brakes of the car are applied from this time to this time for the time when the brakes are applied, for the time. So for this time you have to calculate the distance moved by the car. Since it is a speed time graph, right, or a velocity time graph you can say, and all the velocities are positive, the distance moved is the area under the graph. So which area are they talking about? Let us mark it. They are talking about the area, this entire area, like this. Let us shade this region as well so that we understand. They're talking about this area. The area of this trapezium. So what is the formula for the area of trapezium? It is half the sum of the opposite parallel side, the sum of this side plus this side, which is 32. Here this is 32. Sum of the opposite parallel sides, 32, plus, and what is the magnitude here? Let us plot a line to the y-axis. Looks like that this is 18 here, this side, 18. So this is 18, 32 times the height of the trapezium. This is the height of the trapezium. How much is it? 35, 3.5, not 35, sorry, 3.5 minus 1, which is 2.5. You can solve it and you'll get your answer. So this whole thing becomes 50 over 2, so 25 times 2.5, so which becomes 62.5 meters. Let us check with the mark scheme as well. If the answer is correct, yes. Fine. If you do not remember the formula for the area of the trapezium, you can split this whole shaded green region into two parts. One rectangle, find the area of the rectangle and add it up with the area of this small triangle that you see here. So you can split the trapezium in two parts and you can add the individual areas, or you can use the area of the trapezium. Let us move on to the second part of the question. I have taken the graph again on the second screen, because switching between the screens can get slightly confusing. I have copied the graph here again. So talking about the second part, calculate the magnitude of the resultant force on the car. So where they are talking about the resultant force, if you look at the question from the very beginning, for the time when the brakes are applied. So everything is for the time when the brakes are applied. So they are talking for this zone starting from here to 3.5. So in this zone, what is the force, magnitude of the force which is applied? What is the formula for the force? Force is ma. Do you know the mass? Yes, the mass is already given in the question. This is the mass of the car, 1500 kgs. So let us substitute the value. Mass is 1500 times acceleration. Are you given the value of the acceleration? No, you are not given the acceleration value. But can you calculate the value of the acceleration? Can you calculate the acceleration value? Yes, you can, because it is a speed time or the velocity time graph. So how do you find the acceleration from the velocity time graph? It is the gradient. Acceleration is same as gradient. How do you find the gradient? First, write down the coordinates of the two endpoints. What are the coordinates here? 1 and 32. The coordinate here is 3.5 and 18. So change in y, which is 32 minus 18. So let us write down the values. 32 minus 18 divided by, because you subtracted 32 and 18, so you have to subtract 1 and 3.5. 1 will come first. 1 minus 3.5. So 32 is coming first. So 1, the corresponding x will also come first, right? Do not switch their position. It should not be that 32 minus 18 you are doing in the numerator and you are doing 3.5 minus 1 in the denominator. If you do that ways, your signs will get switched here and there, and you'll get wrong results with respect to signs. If you'll solve this question, if you'll solve these numbers, I mean to say if you'll solve these numbers, you should be getting a negative answer. Why? Because numerator is positive and denominator is negative. So you can solve it in your calculator, and what answer should you get? Let us check it out. Yes, same thing. Minus 5.6. If you see, acceleration should come out as a negative number, minus 5.6 meters per second square, and this tallies with the understanding of acceleration as well. This sign tallies with the understanding of the acceleration. Why tallies? It is a downward going slope, it is a negative slope. Deceleration is happening, and the question also says that the brakes were applied. Brakes were applied means the speed of the car was reducing, it was decelerating. And same thing you got when you calculated the value of acceleration as well, with a negative sign, which means deceleration is happening. You got the acceleration, substitute this in this equation here, and you'll get the value of force. Substitute the value here. So minus 5.6. Do not ignore the sign. You are an AS level student. Please do not ignore the sign. Move forward with all the signs taken care of properly, right? So when you solve it, you'll get your answer as a negative value of force. If you see here, negative 8400. 8400 newtons. So this is your answer, negative 8400 newtons. It is a 3-mark question because a lot of steps are involved. You needed to calculate the acceleration first and then the force, and you took care of the negative sign as well. Therefore 3 marks. Let us understand how the mark scheme awards you 3 marks. 1 of the marks if you're writing the formula for the acceleration correct. 2nd mark if you're writing the formula for the force correct, and the 3rd mark if you're getting your final answer correct, if you're substituting the values correct and the final answer is correct. If you're just not writing the formulas and if you're making mistakes here and there, you'll be losing a lot of marks. But if you're writing the formula at every step, even if your final answer is wrong, still you'll gain some marks. So it is always a good idea that you write down the formulas properly to gain at least some marks, even if your final answer might be wrong, right? So what did you understand? Acceleration is negative, force is also negative. So the part C, the direction of the motion of the car in the question B at time t is equal to 2 is shown in this figure. So which time are they talking about? They are talking about this time. So what was happening at this particular time? Deceleration was happening at this particular time. If you see, deceleration was happening. So on this figure, show with the arrow the direction of the acceleration, label this arrow A, and the resultant force, label this arrow as F. So what is the direction of motion? Ahead. It is a deceleration. It is a deceleration. So what is the direction of the acceleration? It is in the negative direction, opposite direction. So that's your A. The resultant force is also in the opposite direction. This is your force. This is your force F. Both the acceleration and the force will be in the backward direction. What is the length of the arrow? They are not talking about and they are not concerned about it. But both should be in the backward direction. Why is force in the opposite direction? The force is in the opposite direction. Why? Because the brakes were applied. So a lot of friction was created. The frictional force overcame the force of the engine. So overall resultant force became in the backward direction. Friction was very great as compared to the forward force of engine, right? Friction was very large as compared to the engine force, and friction, we know it acts in the backward direction. Engine force, friction and engine. Friction force became very large. Therefore, the resultant, when you subtract these two, friction and engine, the resultant will be in the direction of the greater force, friction. Resultant force is in the backward direction. Acceleration is always in the direction of resultant force. So acceleration is also in the backward direction. This is all about this question, and I'll show you the mark scheme as well. Please do not forget to subscribe to the channel and give your feedback in the comment section. If you like the video and if you have some suggestions on improving the video, please do not hesitate to share it with me. Thank you.